I think
Okay.
I'm
Want me
gonna.
to introduce you?
Sure.
All right. Yeah. So, Sheesh is from Kitware, and he's been working he's been working on a project that's been funded by Idaho National Lab for the last 3 years or so, and along with myself. And so Ashish will probably talk about this, but we started with some modifications of ETK with the overall goal trying to get the ability to do ParaView in immersive spaces. And so we finally got to the point where it's going to be included into the next Kitware release, right? So Ashish is here to tell us a little bit about Kitware, about ParaView, and then about the immersive features of ParaView.
Thanks, Bill. Can you hear me all? Okay. So, like Bill said, I'm going to talk about the Kitware first because I'm not so sure like how many people know about Kitware. I guess they know probably more about CMake or VTK or ParaView, but probably less about Kitware itself. So I'll use this opportunity to quickly go over what Kitware does, and then just clarify that I'm not a salesman for Kitware because Kitware does the open source. So all the work that we have done here in collaboration with Idaho National Lab and Indiana is actually open source work. So it's a BSD license. You can modify the code, you can add things to it, and you can keep it for yourself, and you can actually even sell it afterwards. So that's the nice thing about Kitware is like, in my group, 99.99% work, I believe, we do open source. And when I open source, it's not LGPL, it's pretty much BSD-like license. So it gives us a great platform to actually approach national labs and universities and researchers, and then figure out like what actually you want to do for research and science and visualizations and VR, and not really focus on the like making money out of this whole thing. So with that, so the advanced thing should just work with the click. Is that true? No. Okay, so like I said, the Kitware is a scientific computing company. The history of Kitware is that back in 1990s, Will Schodecker and Ken Martin, they're working for GE, and they published this book called VTK. It's a visualization toolkit, and the idea behind that, at that time, there was nothing, there was no framework, object-oriented framework to do scientific visualization, and they came with this idea, and they published this book, and the book got eventually very popular actually. So they had the good confidence and faith in like going after VTK and start their own company, but they want to keep it open source because they truly believe that by open sourcing this kind of work, you can benefit not only the community, but you can benefit the company as well. So it's a 15-year-old company. And within 15 years, we have now 3 offices. So one is here, where I'm at. It's the Clifton Park. It's very close to Albany, and it's in New York State. And we have North Carolina office, and then the third office, which actually Patrick, and you remember yesterday, Bill mentioned Patrick a couple of times. So Patrick actually was involved with Idaho National Lab, and he finally joined Kitware now. So he's the one that's leading the office in Santa Fe. And then we have the 4th office actually, which got opened like 2 years ago, and it's in Lyon, France. So they do, again, open source work, and they have been working with some commercial companies and some other organizations in France and Europe. So we do actually a couple of things. We
Mike, upside down there. On the right here, underneath. There you go.
better? Yeah. So Kitware actually does a couple of things. So we don't just do visualization. We actually work on the supercomputing. So it's not just about the visualization, but we do actually HPC work. We do medical imaging. We do computer vision, so a lot of the tracking, event detections, those kind of stuff. And then data management, like how do you handle large scientific data And then how do we make sure that it can be shareable across different communities or different researchers. And then it all actually tied to the software process, which is developed by Kitware, which actually uses a couple of tools that we have built in-house. And again, all these tools are open source. So here, one of the nice things about Kitware is that we have developed some nice tools out there. So even though these tools are open source, the quality of these tools is pretty high, and it's funded by different national labs, and they came forward and they actually enhanced some of these tools. So it's not just Kitware actually has done a lot of this work. Different national labs, researchers all around the world has put their efforts into building these tools. So you can see here ParaView today, and then we have VTK, which is the foundation for ParaView, and the Titan is more for the informatics. On the medical side, we have done work, basically it's a toolkit ITK, and with ITK, there are other toolkits and products that we have developed. And on the vision side, there's a library called VXL, which actually works with OpenCV quite well. And on the data management side, we have MIDAS. So a lot of different tools actually, and actually we have developing this new tool called VES, which I'm going to show a demo as well, and how that could be used in the cave. So I'm going to show a movie for that too, because it works with ParaView. So whatever works with ParaView, there's a very higher chance that it will work in the cave right away.
Next question.
So,
Does the volume, on the last slide, does the volume viewer run under, does it have that be able to run under cave?
not yet. Actually, telling Eric a couple of minutes ago is that the volume renderer in VTK actually uses, it's very tightly coupled with the camera parameters. And for the cave, we have added this concept of eye actually. So we have not transported that phenomena in the volume renderer, but actually one of the person on the mailing list of ParaView actually used our VR plugin, and then he changed the code of volume renderer and got the volume rendering working in the cave. And I asked him for the patch, but he hasn't responded to my email yet. So I'm really waiting for his to send us a patch back. But it's possible. It's just a matter of invest maybe few days or a few hours and try to get it working. So this is a software quality process. So it's every tool that we develop as this cycle where we develop code here, by any developers, so it could be actually part of the Kitware, it could be outside Kitware, and we have this central repository which mostly uses Git nowadays, and we have this tools called CMake C-, which actually takes the code every night or continuously in a continuous mode, and builds that software overnight or in a continuous fashion and posts those results to a server which can be which is accessible to different developers. And then once they have approved those changes, then the code goes again back to the main repository. So we make sure that anytime you add a new feature, it's not breaking other features. At the same time, you have a new test for that feature. So it's very much into the test-driven development. So this is showing the dashboard here. This is how the dashboard look like. So the green actually shows you that everything is working and tests are passing, and the red actually shows that there's an error. It could be a configure error, it could be a build error, or it could be a test failure, I guess. So again, like I said, we mostly develop open source software, and the way we make, I think people often ask, me, when I did a presentation like this at the Earth Science Department at the SUNY Albany, they asked me the same question 5 times, like, how do we make money? So I told them that, we make money because obviously, they pay us, but really the main reason we make money, or the main source of, Kitware funding is services and support, technology integration, collaborative R&D, and going by itself to some grants and proposals. So I think we're a well-funded company, and I think we had a good success. These are some of the examples that we have done. So you can see we have worked in different areas. So this is surveys, traditional surveys. These are the older applications actually. So we have shown some GeoWays, InfoWays kind of stuff. So and we can integrate all those things together actually within ParaView and VTK. So it's all available in these toolkits. We have been working on this technology called ParaView Web. So we can do the essence, the rendering is performed, rendering and data management is performed by the ParaView, but you can access those renderings or data on the web browser, and we make it easy for you to write your own custom applications. So again, this is the open source work, and I'm going to show you a movie of that later as well, so you can see how well it really works in a real environment. So this is what I was telling earlier. So we have been, as you see, like the smartphones are out, and everyone has like Android or iOS most of the time now. So for us, it was a very interesting platform to actually show or see if we can develop some interesting applications and visualizations on these mobile platforms. So actually, I'm one of the main developers of our VES toolkit. So what we have done is we actually wrote a VES toolkit which actually supports OpenGL ES 2.0 and well with the VTK, because we have written this Kiwi library which actually interfaces between the VES and VTK. So everything what you do in VTK is mostly supported in VES as well. And that's how we were able to port some of these applications and visualizations to the mobile devices. And one of my colleagues, Pat, actually has done a pretty good job in building this application called Kiwi Viewer, which shows the potential of what you can do. And actually, it's a free app on the iOS and Android, so you can download this and start playing with yourself. So this is a medical imaging thing, and I'm not a medical imaging expert, but we do have like a couple of things we do actually at Kitware in terms of medical visualizations. So you can do registration, segmentation, image analysis, and again, it's all built on this toolkit called ITK, which again is open source. So overall, this is our production platform. So we use Git quite a bit. We just love Git, I guess, because it really gives us a platform that we can work together, because Kitware is like not just Kitware company, but it works with Sandia National Labs, researchers, Indiana. So we have to make sure that we can work with all these developers and researchers, and we have to make sure that we can bring in their code as well back. So Git is really a good platform for those things. And we have used this tool called Garrett for software review. So the Garrett actually is used by Android for their reviewing system. So we actually use same code review system for VTK and ParaView as well nowadays. So it makes it easy for us to use the tools that's already used by other community members and not reinvent the wheel. And again, here's some of the what we can do with the vision side. So it's you can see like there's a lot of I think it seems more like the army is using the vision technologies quite a bit. So here's the FRL doing some tracking, and this is the object recognition funded by the DARPA project. And here's some video-based things. Overall, it does a lot of the basically a lot of algorithms Kitware has developed for image and video analysis. And some of this work is not open source yet, because even though Kitware has a very good success in convincing companies and labs and some of the government organizations to open source their work, with Army it's difficult because often the data is very sensitive, and it's very hard to convince these folks that, hey, open source at least the algorithms. But it's coming together well. We have actually open source one toolkit, and we're going to push that code pretty soon out at the public repository. I think this probably the last slide, I guess. Is it? Oh no, nothing maybe more. Can't seem to get the. Can you hit next, Jeff? Is it frozen? That's Windows. Does anyone have any questions so far on Kitware? Any doubts like about open source strategies that we adopt? Well, so how many people actually do open source here or believe in open source? There's quite a few, I guess. Yeah, one thing actually I learned that open source is great for developers as well. So a lot of my code actually, if you go to like GitHub/Ashish24, you will see a bunch of repositories out there. So it's a great thing for developers as well because I can show my work and I can try to say someone like, hey, I've developed these things. Somebody else can check out those code. Otherwise, if you work in a company where they hide their code, it's very hard to share things. So. So this already I said for the data management, but I'm going to skip that really quick. And again, we built some nice integration of the MIDAS data management with some of the visualization that we have developed. So this is showing actually that you can browse to the data set and you can visualize those data sets right on the browser, again using MIDAS and some of the toolkits that you had developed. Okay. So with this thing, I'm going to go back to I'll switch to the ParaView slides. But like I said, we do a lot of different things. And actually, one of the things that we actually have got some funding now. This person, another colleague of mine, Marcus, he is actually leading the work on the chemistry effort. So the idea is that we want to leverage the work they have done earlier and bringing those work for the chemistry and cheminformatics into VTK and ParaView. So they won this SBIR phase 2 last year. And now we can do some nice, interesting chemistry-based visualizations. So I can't show you today those visualizations, but if you go to the website, you can see a lot of videos that we have for the HPC last year. Steph, can you put me the ParaView slide? Please. Thank you. Okay. So I have 2 slides on the ParaView. So one thing actually I would like to say, I would like to talk about is what ParaView is. And ParaView is not just an application, it's a framework. So I would like to talk about the framework, its abilities to actually do visualizations and computing. And then in the last, I'm going to show like how we actually, it's me, Eric, Patrick, and Bill, we extended the ParaView framework for the immersive environments. So the history of ParaView, like I said earlier, it's basically funded back in the 1990s, and it's primarily funded by the national labs. And the reason for that was, so we came with the VTK, and VTK was mostly serial algorithms, and soon they realized that it's very hard for scientific computing to rely on the serial mode of operation. So they had to do something along on the parallel side to save some time and efforts. And that's where they started funding this project called, I think at that time it's called ASCII Views. They gave us some money, and then we started working on this prototype. And eventually it became, turned into a framework. And all these years, we have been funded very heavily by the DOE labs because they actually use ParaView on a daily basis. So, and they really liked it, I guess. And with their help and with our efforts, we were able to put together this framework in 10 years. And we are continuing to evolve actually. So this is an older slide, but we released 3.98.2, I guess, a couple of weeks ago, and the 4.0 should be released in the month of April. So within a few weeks we'll have the version 4.0 out as well. So what is ParaView? So the ParaView is an application and an architecture for display and analysis of massive scientific data sets. So like I said, it's not an application. I mean, we provide a GUI client for you, but actually you can develop your own custom clients for ParaView or within using the ParaView framework. And the power of ParaView is really that it can crunch all these numbers really fast using your HPC or visualization cluster, and gives you this immense power of either performing the data operations on your HPC and then doing the visualization and compositing on your visualization cluster, and then still show those images on your desktop or the web. So how to use ParaView? So it's really easy to use actually, and I'm not going to go into the technical details of the ParaView architecture, but I'm going to have my email and links in my presentation. So you can always talk to me afterwards if you want to know about how the ParaView actually works. But how to use a ParaView? It's really simple. We have like I don't know, maybe 30 to 40 our own file readers, and we have this widget bridge, so we can actually bring in I don't know, another 60 file formats in ParaView. So I think it's probably more than 100 file formats that we can bring in ParaView. So all you have to do is like you open a data set that you like to visualize, and you construct this pipeline. And once you have this pipeline, you can perform these operations like you can do clipping, you can do slicing, you can do contouring, and all those filters are actually are available to you to the client, but you can write a code in the ParaView itself in Python or C++, and you can do all those operations for your applications. And here's the GUI actually, that you will see later as well in the demo. So here you have, as derived like menu toolbars. This pipeline browser is really, show you like how you can use ParaView to construct the workflow that you need to get the visualization that you need to show, or to either to visualize to your community or to yourself. And then it also provides online help. So there's a lot of wiki documentation. Obviously, it's not very friendly for developers sometimes, but the user documentation is very well put together, and you can access those documentation from the GUI itself. And here's I've shown like different data structure it supports. Again, it's not the full set, but you can see pretty much everything is covered within VTK and ParaView. This is showing like load the data set. You can hit apply, and the way actually it works, because like I mentioned earlier, the ParaView is not a desktop application. It's for the massive data set. So you may actually have to load a partial data set from your server or from your data server. So we allow you to stride to data sets as and when needed if the reader supports it, and then you can look at those data sets or run the pipeline afterwards. You can inspect the data, so you can look at the what arrays your data contains, cell data point data set, what is size, the extents. And actually, one of the nice thing that Livermore has added recently is we can look at like how much memory and CPU resources consumed by ParaView processes right on the GUI as well. So you have the concept of views, and views actually what actually you see on the screen, and that's what we use actually for the cave rendering as well. But here's an interesting thing actually is that when you run the ParaView application on your desktop, it's actually running the client-server mode all the time. The server in this case is the inbuilt server, and we use the same thing for rendering in the cave as well. So there's in terms of for the user, it's all transparent. But we manage all those information really well on the back end. So here I'm showing a visualization, a traditional scientific visualization, and some InfoVis for that visualization. And you can see we can have multiple views all put together in the client itself. Again, displaying the data set, we can do different kind of representations, points, wireframe, surface, volume, glyphs. So there's a lot of choice available here. View options, there's a lot of, you can play around with some of the view options as and when needed. Multi-views, we can do multi-views. So you can bring in the, like I was showing earlier, you can have the scientific view and then the InfoVis view all in the same render window. And then we allow you to control representations, basically like, how do you want to, for scientific viz, it's very important you get the lookup table right. And yesterday when Bill was showing some of the volumetric data set, you see the power of like, putting the right transform function really helps you separate the noise from the actual data or actual information. So, VTK and ParaView allows those kind of, setting the right colors and setting the right lookup table, and you can scale by the temporal values, or you can scale by the data range itself. So again, different kind of controls allows you to to basically configure your visualizations as and when you need it. And again, here's just talking about the transform function. So just like in Bill's demos yesterday, you can control your transform function for volume rendering or just for the geometric rendering, and that gives you the right visualizations as you need. Different kind of filters. ParaView has a whole bunch of filters that it comes, it made you accessible right away, but you can add new filters as and when you need it. So some of the basic filters we need is contour, clips, slice, threshold, and actually for the VR demo, we are going to demonstrate doing the slicing in the VR environment. The stream tracer is actually going to show as well. And then you can do extract group datasets, warp, and glyphs. So again, a bunch of filters for your use. The way the pipeline browser works, and actually this kind of is good to know because when we create these visualizations for the demo for the VR, we actually made sure that we get the right visualizations. And it's important to understand what this really means. It basically means you load this data set, you ran this contour filter, and that's what is currently visible right now. Then I extracted the surface on the contour, but I didn't want to show that extraction operation to the user, and then I performed the clipping afterwards on that extraction, and I want to show that to the user. So you can hide and show different stages of the pipelines as and when you need. And this is important part when you're doing any kind of VR stuff, any kind of VR visualizations. You have to know what you're doing to give you proper visualizations within the VR environment. So again, we have a bunch of file parameters. It's showing you different data types, points, cell, block. And then this is just showing the pipeline, like how the pipeline works. Again, I'm not going to go into detail. It's just basically we have an idea of representations and views and filters. But I guess these concepts are pretty common. So I'm assuming that you will know that, or you know that already. Again, so if you want to learn more about ParaView, we have like a whole tutorial page that you can just go on and then start trying some basic visualizations, and you can do some operations that are shown here to get to a view that I've shown in the slide at the bottom of this page. So again, I'm not going to go into details like how you create all these visualizations. I'm going to just skip those things. And again, this is the analysis part. So you can perform all this analysis within the ParaView. Now, one other thing actually, which I'm not going to show in the VR demos, but you can perform the selection operations very well. And if the community, if we haven't really have anyone come out with this use case, but if you want to perform these data operations within the cave, just basically selection operations, then it's just a matter of like writing a new interactive styles and send that information to the ParaView server, and then it basically shows you the selection for the points or the cells. So again, it's easy to add. It's just a matter of like somebody implement those interactive styles. Again, the selection, we can do different kinds of selections. You can select cells, you can select points, or you can perform intersections, you can improve the data sets. Again, various operations you can perform within ParaView. One of the nice things about ParaView is like you can export all these visualizations as PNG or movies. So if you have like animations, you can export animation as movies for if you want to put it on your website, or if you want to take it for your conferences and whatnot. And recently we have added the support for the exporting the image as a vector graphics. So you can really produce the high quality images for your publications. it's one slide why it's called ParaView, and then it's really come from the fact that it's a parallel visualization tool. So that's why we call it ParaView. And like I said, it's the main objective of the entire ParaView is visualizing massive datasets. I mean, you can use it to actually look at some smaller datasets, but the real power of ParaView comes when you try to load massive datasets and then try to visualize and analyze those datasets on your cluster. So here actually this slide is very interesting, and this is pretty important slide because you see the ParaView architecture actually has three tile architecture. So you have data servers, which is right here. You have render server, and you have client. So client, you have see the GUI earlier, so that's the client. Now render server is actually what we use to render the views in the cave environment. So so when you render like 4 windows on a cave, or in this particular case, if you have 4 walls, each wall is a render server, and then each render server can be connected to the data server. So this data server could be on your HPC, and it can the data server actually can perform the data operations, which can be then bring it back to the render server, and the render server can do the compositing for the tile displays, or it can do the rendering, is what we're going to do here today. And then the client is just to control different operations. So again, this is the data parallel pipeline. I'm not going to the details of the data parallel pipeline, but basically, like I was saying earlier, is that you read the data on the data server. So this is mostly HPC. You perform isosurface, and then you send the data back to the render servers. And then there actually you can render the data set, sort, class, and composite for the tile displays. We don't do for the cave displays because in our initial experimentations, we found out that doing this kind of, so we use this library called ICE-T, and doing any kind of compositing work on the render server actually was below 15 frames per second. So we gave up on that idea, but we directly call OpenGL now instead of like doing rendering and then compositing afterwards. Again, couple of data sets we have shown here, extreme large data sets. I actually have, I work on my climate projects where we use ParaView, and the data sets actually, like, for a year, it's like I have, for a smaller data set, the smallest data set that I have is like 768 gigabytes. So again, that's where the power of ParaView comes in. Here we have shown half billion cell and half billion cell asteroid, and then Sandia and some of the national labs have used ParaView to do the visualization analysis using for those large data sets. And this is again I'm going to show on the VR demo. So, like I said, the PV server is actually a server. So the client actually connects to the server, and you can configure all these things, and you can save those configurations. You don't have to do all this operation every time. But here, basically, you give a name to a server, and then you specify the server types. So in this particular demo, actually, it's just a PV server that we are running, and you specify the port, and you can leave default if you think that's the right value, and some other information that host and then the port, and then you can hit configure, and once you configure, you can save the configuration for the next iteration. And so here's the compositing thing I was, this is mostly for the tile displays, where we actually tell one particular process to render or process data for, in this case, like half of the sphere, and the other one does the other part of the sphere. And then in this particular case, this is the master node. So it's doing the blue one, and then it's asking this to render this half of the geometry of the sphere, and then it's bringing it back, doing a compositing to make a complete sphere or the image of the sphere, and then sending it back to the client. And the client is actually just showing the image for you then. But this particular feature is tile displays because for the tile displays we found that it kind of works. Tile displays are used not as interactive as in the cave. So even if the performance lags, I think it's okay. But in the cave we didn't want the user to suffer from the lower frame rate, so that's why we chose a different strategy there. again, this is something actually to do for our VR stuff. The idea is that, well, it works right now within the ParaView, so we can control the level of detail you're sending to the to any display or any visualization that you want. Then what we want to do for the future is that, depending on where the user is looking at in the cave, we want to say like, hey, send high resolution data set on that node, and send a low resolution data sets on the other nodes, because we want to basically give more information where the user is looking at, and not overloading the other systems, because user is not looking at those screens or those views. Again, it works for both. You can do when you're doing compositing, you can do level of detail for the images, or you can just do level of detail on the geometry itself. So like I said, it supports tile displays, and there are some folks that are running ParaView on the tile displays, and I'm going to go to the next slide. But before that, actually, I'm going to do a demo and talk about like how easy it is to configure the PVX file and the interactions. One thing I must say that the interactions is pretty much basic right now. Primarily, what we want to do is we want the community to come forward and then implement those new interactive styles. Our goal was to provide a framework and do minimum work, because just to show that it's possible and it's usable, and we want the community to implement new interactive styles. So right now we have 3 of them, and we're going to show all 3 of them today. So let me run a demo, and I think I need Simon's help here. So here I have, we already created the scripts to run PV server and the ParaView server. So let me show you how it looks like. Since we want to demonstrate the ParaView running on Windows and Linux both, so in this this first set of demos, we are going to show the ParaView up and running in the Windows. Or maybe just make it big. Could do fonts. Yeah.
There it was,
Yeah. Okay. So the Microsoft MPI works really well on the Microsoft, which should be. And here, so we run the MPI exec with 3 processes, and it's just a mapping 1-to-1 with how many displays you want to configure. And then we say, you want to run this process, which is a PV server, as I mentioned in my slides, and you provide a PVX file, which in this case actually is build has given me, and then I just modify it to work with my demos. So let me show you this file. So here, it's a very simple file, and actually we would like to extend it for a bit more complicated scenes, but for now it's pretty simple actually. So you specify the different configurations for the server, which in this case the PV server. And the first thing you say, this is a global value, so you want to say eye separation. So in this case, it's 0.166. Now the ParaView doesn't really care about the units. So whatever the unit the tracker is coming in is going to use that as a number. So you have to make sure that those numbers actually mean something to you, whether it's feet or meters or inches. And that's how you put those values in as well here. So then the next thing is how many machines you have. Now the ParaView works both on the shared memory systems or on the cluster. So you say, in this particular case, since this is not a cluster, it's just using quadruplex, I'm going to specify the geometry, and I'm going to offset the geometry to basically put my render window at those locations. So here, I want just name just I know that which particular wall this is actually going to display onto, and then on Windows this is pretty much useless thing, because on Windows there's no display ID concept as such like in Linux. So you have the geometry, and then in geometry you specify I want this much dimension, and then my offset from the origin of the display would be 1400. since I'm not going to do rendering on the left wall here, so this is like 1400 bits. So I'm going to put that my first window, which is my front window, is at 1400 pixel offset. And we just add some convenience values here. So we say full screen 0, show border 0. But again, you can turn them on and off. By default, it will be full screen unless you tell not to. And then these are actually the numbers that specify the display port of your front wall. So these actually are using meters because we are running VRPN server. So this is just a configuration which is like, where is the lower left? So lower left is right here, and then you say lower right, which is right here, and then you can do upper right here. So then you just put those numbers, and these numbers are basically in negatives because the origin is somewhere on the floor in front of the front wall. Same thing for floor, and same thing. So we have floor, right wall, and right wall actually we have the offset of 2800 because it's a wall next to the front wall, which is actually at offset 1400. And then for the floor, it's actually for the windows here. It's pretty much a panorama. So it's like one after another wall. So the third wall is at the offset of 4200. Again, it's pretty easy to configure that. So here, so once the PV server has to be run on this to do to open the port, display on these walls, but then you want to run the client as well, and the client doesn't need to be on the same system. The client could be on anywhere as far as it can connect to those machines where you're performing those renderings. So you just say stereo. So you want to enable the stereo on the ParaView side, and you will say -s stereo -type equal to crystallize. Now ParaView supports I think 8 or 10 different stereotypes, and recently Patrick and I added the side-by-side stereo for as well for the 3D TVs too. So you can specify those options as well. So let's run PV server, and before that, looks like the VRPN is still running, I think. Let me show you. Well, the VRPN config is whatever would be your standard VRPN config, and this is nothing ParaView specific actually. I just compiled VRPN and run the VRPN server with a given file name, and this file name just specifies that I'm using dtrack, which actually we are using here at the Indiana. So you run PV server, and PV server is saying it's accepting connections at this host time at this port, and now I'm going to run ParaView. So here it is, and let's hope it works. So here I configure the local host, and we can see that I have said that I want to do client server only because I haven't configured the data server part here yet. The host name, the port number, and then in this case I said manual because I'm launching the PV server through the batch file, but you could actually copy and paste the same command line here as well, and you can say command. So whatever is convenient, you can do either way. Okay, so I'm gonna select this local host, and I'm gonna hit connect, and let's see if it shows up on all three. You should be able to see the display is opening up there. So now you see that it's showing up the display. It's not showing the axis on the floor yet because we haven't put this feature in yet. Right now, for the configuration point of view, the origin is on the floor, and so basically your eye is sitting on the floor on that display. So it's just like the singularity happens on the floor right now. So as soon as the head tracking is on, you will see something on the floor as well. Okay, so this is So one thing which I have done already to save some time for us is I have built this plugin called VR plugin, and that's what actually we worked with Indiana and Idaho to implement this new plugin for the immersive environments. And it's pretty easy to load. You can just say load new, go to the directory and load that plugin. And once you load that plugin, you can say auto load, which I've done in this particular case. So it loads next time every time when you run this when you connect to the server. And then the same plugin actually gets loaded on the server side. If you don't do that, then it gives you an error. And once you load that plugin, it comes with this panel. Again, this is something we actually have developed in recent time. It's a start. I won't say it's a finished product yet, but it's in the working stage. And what we want to do actually with this GUI is to make it easier for users to configure their systems. So let me show you how easy or difficult it is. So here, you have two options. Well, in this particular version, I didn't compile Brewy because Brewy does not work on Windows as far as I know. So I just have built the plugin with the VRPN support. So that's what I have seen on my drop-down. And I'm going to type in the address for the tracker, which is actually dtrack at localhost. And I'm going to start configure things here. So I'm going to say tracker. Now this thing you have to know in advance, like how many outputs you have for each type, because the ParaView would not know that. You have to know that, and whoever is setting up your tracking system would tell you that, hey, I have these many inputs in analog buttons and then tracking. So I'm going to call it head. And actually, Bill can do a better job than me on this particular case here, or much faster than me. But you can see here, like I put like tracker 0, or the session 0 is head, my session 1 is want. And these are just the names that I'm going to refer to later. So the names could be anything you want. It doesn't really matter. And in this particular case, I'm going to just use, I'm going to configure only 4 buttons. So there you go. So we have 4 buttons and then 2 trackers. I'm going to hit OK. So now it shows you, like, how many connections you have. So you can have multiple connections. And one of the things we have done for the supercomputing is that we ran 2 VRPN servers. So you will see 2 VRPN connections here. So you can have multiple VRPN connections, or you can have multiple VRPN addresses. Okay, so then here you see, like, again, bunch of drop downs, and it says interactions. Right now it's empty because we have not configured our interactions yet. And every time you actually add a new interactive styles, those options gets filled in automatically. So in this particular case, it also knows actually what properties are compatible to each other. So for a render view 2, there are 2 properties that you can use tracker or any data set from the input devices. And that's why it's showing you all these options that you can perform from those interactive styles. So I have like slice interactive style, I have grab interactive style, and I have the track interactive style. So in this particular case, I'm going to select the render view 2, I transform, and that's basically going to do my head tracking for me. And I'm going to say I want to track this thing. So when you hit add, it's going to ask me which tracker you want to use for the I transform matrix, or for the I transform, which is your head. So I want to use the VR connection.head because that's what the tracker is giving me for my head tracking. Okay, so I got that. Now, this is another interactive style that we have developed. It's a grabbing. So again, it's nothing special. It's just a basic grabbing the wall and rotate and translate. But now you can do grab instead of the track because you want to do more operations on it. And you say add, and now it tells you, like, I want these 4 things to be filled up. So if you haven't configured your connection properly, then you can't really run this thing. So you need to have at least 3 buttons, for this thing to work. But again, this is just a thing that we have, put together for the basic use case. If you have some interaction that requires more or less inputs, you can always do that. And then you can inform the ParaView, like, hey, I have these many inputs I want for this particular interaction. So I think we did 1, 2, 0. And then I want to use the head because head is used by the head tracking. So obviously I'm going to pick the one here. And then that's it. I'm all set as far as these 2 interactions are concerned. And here we have shown you that where the camera is set. So the camera actually in the VR world, it just becomes the view matrix because the primary reason to separate the eye versus the camera is for the backward compatibility, and then to give this additional flexibility to the users. They can control the camera, separately than the eye transform. So it makes it easier for people to, different things, whether they are doing on the desktop versus the VR environments. And we did some work to expose some of the APIs to make it easier for developers to control how they want to track the head or the wand. So I'm going to draw. So again, you see here, I have a bunch of sources, and sources are just basically to draw a cone or some other data sets. And then once I select a particular source, in this case a sphere, you see the sphere is drawn on the cave as well as the client as well. And I'm going to change the radius of the sphere. So now it looks like a sphere now. And once you select a particular source, now you have a bunch of filters at your disposal. So you can see there's a huge list of filters that you get for free. And if you need a particular filter for your own particular visualizations or operations, you can always do that. Okay, so I'm going to ask Simon actually to demonstrate the basic interactions with ParaView on Windows. So again, this is doing the head tracking. Is the scale is off? Okay, let me do the scaling thing. Hang on a second. So what Simon actually has told me that the scaling is off because the data set is coming in meters, and when he's trying to move that object, it's a pretty tiny object because the radius is only 0.5 meters, so it moves quite a bit. So it depends upon your scale of the scene. You can either scale it here, and one of the things that we want to work on in the future is that we want to scale the scene either through a auto mode or provide a GUI option here that you can scale or track a data set. Actually, the option is there in the state file. It's not just exposed in the GUI yet. So again, we are doing translations. We can look around. You can put the sphere on the floor. You can jump. I don't know. And actually, this is the Windows in the debug mode. So, when I came here on Sunday, I wanted to make sure that if something happens wrong, I could debug it afterwards. But if you build on Windows, it makes a huge difference when you build and debug and release. So if you build on release mode, then it's much faster. Although in this case, the sphere is pretty small geometry, so it doesn't affect us. Okay, so that's that. So let me, just for the safety, I'm going to run I'm going to show the Shuttle now. And Shuttle is a bit larger data set, so it's going to have some performance issues. And primarily that's because I didn't build the Windows, the ParaView and release mode, and I didn't optimize the geometry yet. So consider that when you look at the performance issues. So actually in this case, since we already had this working and it already remembers the state and everything else, I'm going to just select the state that I was running yesterday, and let's see if it works. Hopefully it will still work. And we already configured the interactions for this one. So here it's asking me if this is the right location for the Shuttle data set. And I'm going to say yes, because I know that that's the right location. And it takes a while. Actually, it's showing up that thing. I didn't move the window, but it's actually doing the progress bar at the bottom of the ParaView. Okay, let me do a reset, Simon. Okay, and start. So this feature actually going to show the, before Simon, you do the interactions, let me talk here about this pipeline really quick. So like I was mentioning the pipeline in the ParaView, again, the pipeline just works in the cave or any other tile display or the client, doesn't really matter. So what I've done here for the pipelining, I load this data set, which actually came from NASA, I believe. I extracted the surface, I did a reflection on that one, and And for this particular subset, I again extract the surface and then reflect 2. Again, it's just how I'm building my scene. And I add this filter called stream tracer, so it can, you see all those lines, so it's tracing the streams for that data set. And then I have some other operations here, which is contour and whatnot, which I'm not showing at this moment. So again, you can do whatever you want. We don't really care as such, as far as it really satisfies your needs for visualizations.
I have a question.
Sure.
Is it all synced? So if you mess with the visibility on the GUI there, does it transfer to the...
Yeah. It's all synced pretty well. So you can turn on and off things. Like right now I'm not showing the reflect 2. Actually, the reason I'm not showing all the data sets because the, it's on Windows, it gets a bit slow. Plus, I have my debug build, so it's kind of a bit slow. But if you have, mostly these things perform very well on Linux. But if you build on Windows with release and make sure that you optimize your scene, it works pretty well as well. Okay, so let's see if Simon can do the stream tracing for us. One thing actually we have not done is we have not, this interactive style is new, so we haven't fixed the transformations. So it's not as smooth as to move the stream tracer point, but it's usable. With some, with few hours, we should be able to get to a point where it should be very easy to, move the seed point of the stream tracer and then draw new lines or draw new streamlines as you wish. Again, it's all interactive, and like I said, we don't, the Kitware, we don't really have a cave. So we can't really do all the testing. So we rely on, Bill has been helping us a lot, and thanks to Bill. And Eric is here, and he helped us a lot. And then some other labs and people actually has helped us testing some of these features. But our intention is actually to provide a platform. Our business model, it's not driven by the VR, but we do like to support VR because we do realize that people in different national labs and researchers, they use VR for different visualizations, and since ParaView already has a very nice framework for some of these scientific visualizations, by extending ParaView to VR, we can support the other researchers that they want to use ParaView for for their immersive visualizations. So again, you can see the scale is not right here, in the sense that we made the shuttle too small. So when you move a small bit, it moves quite a bit. So that's the thing that we need to work on. Actually you can do all those things in your interactive style. It's just that I have not done that kind of scaling in my own interactive style. But the user can grab everything they want from the ParaView, and it's not that difficult because once you understand ParaView framework through proxies, it's easier to get things done. But it takes a while to learn those proxies things. So it's not as easy as I'm saying. But with some experience, you can start developing your own interactive styles, and we can certainly here to help. Okay, so that's that's working, and we're gonna do a demo after my another slide. We'll do a demo on Linux, and we'll show the slicing working on different data sets too. Any questions so far? Okay, so let me. Oh. So as you can see, I'm not a big Windows user. Not that one. Okay, so let me talk about the ParaView Immersive, since now you have seen the demo. So again, the initial funding actually came from Idaho National Lab, and Patrick and Eric is there, and Patrick at that time was at Idaho National Lab. And actually, let me tell you a bit about my background. So I graduated from Iowa State University, and my advisor was at that time was Carolina Cruz Nira. And at VDAC, I developed a bunch of applications using VR Juggler. and I was the part of their team doing some of the Java GUI development for VR Juggler. And then later I was hired by Arizona State University, and then with Anshuman Razdan and Dr. Gerald Fallon, I set up the Decision Theater, which is a seven-sided VR system. And then eventually I joined the Light 3D at Louisiana, and Simon was there. So that's how I got introduced to Bill. So we started meeting with Bill and Eric and Patrick, and actually I was on the phone with Patrick, and then we were like, I was like, hey, I'm at Kitware now, and and he was like, hey, so you can help us, developing a plugin for ParaView, so we can start using, ParaView in our caves. So I was like, sure, and then that's how the funding started, and thanks to Eric afterwards, he continued supporting funding for that work, and that's how we built this particular framework. And actually, you will see some pictures where Bill actually is doing some of the testing using just pure VTK without this access, a new off-access stereo. So it's in many ways it's Bill's baby as well. So again, it's kind of team effort, and Simon helped us quite a bit on different venues too. So again, team effort here by different folks. So I can't take credit for by myself. I think it's a lot of work from other folks too. So I showed the demo, and I'm going to show this demo on the Linux side as well. So I think with now I can say that the ParaView supports virtual environments. Again, I want the community. We want the community to come forward and implement new interactive styles, because we don't have a cave, so we can't really test some of these things. We do have some funding with some projects, but it's mostly setting up the ParaView on their systems and not necessarily doing new development. But we actually are working with different people, including Bill and other folks, that to improve the features and fixing some bugs as we work on these things. Like I mentioned, initial work is came from Idaho National Lab, and here actually you see the picture of Bill, and I think this is the VTK Tickle application that Bill has developed at that time, using the and what I think you were testing, Bill, at that time was the off-axis stereo on your cave. So I just took this picture because I think it's interesting that he did this kind of work, and that was a big help for us to figure out some of the bugs. And the goal of I didn't say about the goal of this work. The goal is when we started working on this thing, to provide an open source solution, because I'm not against any companies that sell their VR tools or things like that. But I think for the scientific visualization, it makes sense to provide an open source solution, so that you can extend your own, extend the visualization that you want, extend the interaction that you need for your specific environment, and then push your code back to the community so that others can use it in a way that we can collaborate. And I think that's a big thing to me, to push things forward in the VR community. And the other feature was that you see a lot of these tools out there. Again, I love all those tools. I was one of the VR Juggler developer. I use OpenSG, I use OpenSceneGraph, and again, nothing against those tools, but a lot of these tools that you see actually they don't actually support visualizations. They provide you a framework, but also they don't actually have any support for HPC, so you can't do large data processing and rendering. So when we are doing some design reviews initially at Kitware, I was kind of against using any of the external tools, primarily because the idea was that ParaView already has those features, and combining ParaView with, let's say, VR Juggler would be a bad thing, because VR Juggler has 20 dependencies, and ParaView has, let's say, 10 dependencies, and once you combine these two things, it's like, you are looking at a package which is 600 megabytes with 30 dependencies. So we didn't want to do that. And actually, some of this motivation came from Bill as well. Free VR is pretty small library, and ParaView is nowhere a small library, but still, I want to keep that notion for the ParaView. So.
I was just wondering that since one of the common things that happens when you develop a library from scratch like this, if you've been able to support all systems that you haven't run into yet, like head-mounted displays.
Correct.
Or
So
are you basing it more on supporting cave systems?
So that's a good question, actually. So one thing we did not do, like we didn't do everything from scratch because, like I said, the ParaView already has supports for like synchronizing different tiles and different displays. So that came just for free for us. The HPC part just came for free. The render server was working on tile displays already. What was missing was the off-axis stereo and the interactions, the basic connection to VRP and RUI. And then how do we configure the display so that it works on the cave? Actually, they had a PVX file before even we started working on this thing. It wasn't right, actually, so we fixed those things. So the initial work we have done is for the cave only. It doesn't support HMD. But I was talking to Simon the other day, and I think they are using HMD at the location that Simon has. So we may be able to like extend ParaView. It should be easy. It's just a matter of like saying that hey, screen is not fixed anymore. The screen is also now moving along with the user, right? So when you move your head left and right, your display is also moving. Whereas in the cave, your display is fixed. So it's a matter of like how do we configure, how we can put a new thing in the well, the API is there. It's just a matter of like updating those dimensions or the corner points of the displays as your user moves head or move his body in the environment.
Yeah, I'm just mentioning that because I've gotten docked before for my work of like if you only support caves, like so there's also such a large percentage of HMD.
Sure.
And it's like I don't know, it's definitely.
Yeah, no, I think we would like to support that. I think Simon is. So we do have some email list with the ParaView VR. So there's a couple of people actually have been using ParaView VR now, and they ask they asked for some big bug fixes and some features, but nobody has actually came forward for the HMD yet. And actually, Simon was the first person I talked to yesterday, and then you are the second person, I guess. So definitely, I think we would like to support that. It's just that nobody before coming here has requested this particular feature, but it should be doable. Should be easy. And then last thing I would like to say is that we want to support the existing VR communication tools. So one thing actually, we didn't want to reinvent like the communication protocol and things like that. And like Bill and other people have shown the RUI work. So we still wanted to support RUI communication protocols. So we have developed the RUI plugin or RUI plugin within the VR plugin that we have, and then. We use VRPN because VRPN is such a nice library in terms of like how many devices can support. So we just use those kind of communication protocols.
I was just confused. You said you're using RUI.
Yeah, so we actually when you build the VR plugin, you can say enable RUI or enable VRPN,
Okay.
and it builds the RUI plugin, which basically implements the RUI protocol. So all it does, like it listens on a socket right now, and then. Actually, the code came pretty much from Bill for that part. As since we know the protocol, we just decode that protocol and then use it for our interactions. Again, the idea was not to replace anything. Use the existing tools as much as you can if it makes sense. And then finally, I want to say that we want to facilitate the collaboration with universities and national labs and other researchers, and because the ParaView or the Kitware, its strength is visualization and HPC. The VR is to help you, support those kind of needs, whether it's visualization or HPC. So, we are building this VR thing just to help researchers out, and also helping us as well, so we can start working with these researchers and do some more interesting work, whether it's VR or non-VR. So again, you've seen like Conduit and some of the libraries, which actually like even the MATLAB thing. So they're very nice. They have their own advantages, I guess, in terms of like what they can provide. But there are certain limitations as well. Like they don't know the they know the view system, but sometimes they don't. When you start doing LODs and those kind of stuff, it gets trickier. Because you're limited by you're doing a GL intercept and then sending it on across, so you don't know where the actual data set is. But the other problem with that is like with the Conduit is they have their own GL drivers, right? So in my experience, I think it got better along but when you start doing this 2-driver thing, if NVIDIA supports these shader things, then it's hard to do that through this Conduit GL driver or some other GL driver. So it could have some conflicts there. But again, it really depends upon like what you want to do. Sometimes those frameworks works really good for you because you don't want all this features maybe, or you don't want all these complexities dealing with the actual rendering on these walls or those cluster systems. And you maybe just what you're trying to do is you can just get away with installing Conduit on Chromium, or if it makes sense for you that you want to perform rendering on the server side, which is on on your visualization cluster, then I think ParaView it has an edge there because it uses GPU directly. So anything you can do with your GPUs is pretty much directly supported by ParaView. So I think that's a big advantage. But again, it's an advantage only if it makes sense. If it doesn't make sense, then I would say it's it doesn't make a difference for you. The other thing is it really enables users to use HPC. So like I said, we can configure the ParaView with the data server, PV server, and then the client. So it really separates this notion of data processing with the visualization. So again, if you don't have the data set, if it doesn't make any sense for you, you don't need to configure those things. But it's nice to have those things because you will see nowadays that big data keyword is everywhere. Right? There's a lot of government agencies out there funding big data work. So if you're not supporting big data, I think you're lacking a big funding resource to do some interesting visualizations and computing. So having a support for big data, I think, is a big advantage. I think in this generation for any kind of data sets, whether it's social data sets, scientific data sets, or any other interesting data set that you may have. Again, we implement the off-axis stereo. It's probably standard in all the nice tools like FreeVR and Rui, but not every tool out there implements that particular stereo mechanism. It's just to make sure that your eye is relaxed and comfortable. Sure.
We have like a high-performance cluster at Duke, but the one time I tried to do an MPI experiment with it, it was kind of difficult because their entire notion is on batch, like you submit a job,
Right.
be processed, and that's
Yep.
their whole like kind of workflow setup. And I was just wondering, because this requires more of a real-time, if you're going to use it for the visualization, you can't just submit a job and not care when it gets done. You have to.
You can do both actually. So ParaView has something called PV batch. So you can have your your pipeline, and you can just say, hey PV batch, run this thing on the server, and then it can notify the render server that hey, I'm done. So it does provide you that option that you can batch process those things. You don't have to do the live thing with our architecture. But say that I've not really configured so far in such an environment. But if somebody, if you want to try it, or if somebody else has a need for that, we're definitely, willing to help, supporting those kind of configurations and see if we can support your needs, I guess. But ParaView already has. That's the nice thing about ParaView is that it has already solved those issues with the, batch processing, communicating with the data side, and say, hey, are you done? This open chemistry thing that we have actually, we got the SBIR, is one of the initiatives that you can, this tool called Molecule, and you can submit those jobs on the server, and then it keeps you notifying that, hey, what's the status of that job, and it can bring data back to the client side once it's done. So again, it depends on what you're trying to do. It can help you a lot. And one of the climate projects that I work with, the Sandia National, not Sandia, but the Livermore, we actually use that to bring data back and forth within the ParaView framework. So again, it's an open source, Molecules open source thing. There's a mailing list, and it's meant, it started from the chemistry initiative that Kitware has, but it's really meant for any scientific visualization, and we are trying to leverage that framework for different applications at Kitware. And like I said, we use this VRPN and Rui devices, Rui for input devices. And again, the instructions are basic here. So whatever instruction we have shown is it's basic. I won't say they're advanced. Again, if somebody has a need for that, we are more than happy to help implementing a new interactive style. So let me quickly talk about how it works. So what we do actually is that we gather data on the client side, and that's where sometimes it could be confusing. Is that the client actually sends the data back to the to the PV servers, and we want to do that for the input devices. because we want to have single point that we can say, hey, you talk to this, this host or this machine or this device, and then we will take care of distributing the data, that device data, to whoever wants the data actually. So that's why it makes it easier to configure. It's less hassle, and actually the juggler actually, in fact, has moved to something similar as well. So you just say, you get the data on the client side, and here we also configure some camera parameters that's consistent across all the nodes, and then we send those information to the render servers. And again, here as in three-tier architecture I've shown, the data server could send data back and forth from the render server. Again, here it's just showing that you can have multiple VRPN servers, and then it uses the asynchronous event queue, and then dispatch that queue to all the interactive styles. So all the interactive styles get all the events all the time, and then they can say, hey, I don't want this thing because I'm not configured to handle this particular key or particular data set, and they can just let it go to the next one. Or you can actually say, I'm the only one that wants to deal with this particular interaction or this particular input device. So you can say return false, and it won't propagate to the next interactive style. So there's some basic structure to support interactions. So with this, again, we have Kitware has a good team. A lot of my colleagues are, all of my colleagues, I think they're pretty smart people, and they always experiment with new things. And fortunately, we got some funding to experiment with those things. So here, I'm going to show some movies really quick. One thing actually I want to show is that we worked with the PCL folks. Actually, we had some funding, I believe, and we had a paper at IEEE CVPR, I think. It's a vision conference. So we had a paper last year on that. And what this guy has done is he implemented the point cloud streamer within the ParaView. So he's using point PCL library and then reading the point cloud datasets and bringing it directly into the ParaView. So again, let me show you this demo. And actually, this is actually running on the mobile. So it's not this is not showing the live streaming of the point cloud. So it's going to show you pretty much all the functionalities that we are doing with the. So this is actually running ParaView, and we are controlling this thing on the mobile devices using VES. And here you can see it's doing the. Actually, it is live, in fact. So it's sending the live data of point clouds directly into the VES. But the point clouds are actually coming from the ParaView. So again, different data sets, and we are using iPad, I believe, generation 3. This is the latest key viewer that I was mentioning earlier, and we are doing some. We just have key viewer just shows you what the possibilities are with the VES and VTK. This is I call it extension. So you can use some of these tools in connection with VR or tile displays, and interact with different data sets. So again, it's using actually different. We have both for Android and iOS, and the rendering is performed using OpenGLES, and we built this new library called VES. Actually, it's pretty much I built this library from scratch, and then Pat has built this nice library called Kiwi and Kiwi Viewer to use that library along with VTK to do filtering and rendering. So again, he's showing this demo of a SIGGRAPH paper that can do the wireframe rendering in a single pass. And then here we are showing different interactions again, different data sets within the Kiwi. So let me move on to the next one. So this one actually is showing the the controlling ParaView using Kiwi Viewer. So here he has the ParaView up and running on his Mac laptop, and then he is doing the interactions on the iPad. Again, actually it's as easy as if you can access that server, you can just type in the host name, and then it can start sending the data back and forth between the Kiwi Viewer and the ParaView. Um,
Or is it a one direction?
I would think it's listening on a socket. So I don't know if it's tried with multiple clients or not, or whether it supports multiple clients, but it should be possible. Because all it's doing is basic, all it's doing is sending data across sockets, I guess. So there's a plugin called Mobile Remote Control. And again, just same as like VR plugin, you can load that plugin as well. And then it starts open a socket and then communication with the VES. So it's showing different steps. Again, you can start, stop, just like I'm going to show that feature in the VR plugin as well. So you can start, you can start this interactions, or you can stop the interactions. So again, so here we have shown that it's just a matter of like putting the host name, and then you can just hit start and start sending the data back and forth. So again, it's pretty interactive. It works really well. So if that's what you need for your cave, or you want to use this particular plugin for some research work or user studies, we are more than happy to support those kind of things. Again, our emphasis is to show what the possibilities are. We don't actually have a real project right now that uses this feature, but eventually we might have that. Right now we're just trying to see how far we can push ParaView and some of the mobile technologies to bring it together to do some interesting interactions. Possible in the cave, possible in the tile displays, or your desktop. Okay, so let me show you the ParaView web. So, so the idea of the ParaView web is actually doing the visualization on the web browsers, right? So here we have the web browser. So now there's something called ParaView web, and it can do basically it can connect to the PV server just like our client can connect to the PV server, and then it can ask for the data or the renderings, basically the images, and it can bring it back on the browser side, and it sends, depends upon if it's a WebGL renderer or if it's just sending in images, it sends data back to the PV server saying that, hey, I have this mouse at this location and this interaction happened. Then the server sends that information or something back to the client side to react to that interactions. And now, again, this is an extension of that. The thing is, it's a very interesting thing because we're trying to, there's a lot of possibilities here. We're trying to combine the web with the mobile, with the, with the remote renderings, and along with that, we can with the VR. So you can combine these things in various possible ways. So there's a lot of possibilities here. And again, all these things, so this is a sign of Kiwi Viewer, all these things actually that we have developed are open source. So the source code is out there. If you need that kind of feature, grab the source. If you have any issues understanding or there's a bug, let us know, the mailing list knows, and then we'll try to fix that. I think that's pretty much it on the as far as the slides is concerned. And now Simon is going to help me out with the demos. But just a few words here. We want to support the volume rendering. Like I said, it's almost working. We need to update the VTK volume rendering code to use to consider the eye parameters as well when we are in the cave mode. It's just a matter of time. We would like to have more interactive styles. I think we've done a decent job with the basic interactive styles, but we still have some features missing that will make it super easy for users to configure these things. Again, we are looking for help and support from community for those kind of stuff. And as much as we can do on our own time, we'll push on those things. We already support the transformations per tracker to deal with different units, but we could do a better job in providing which units your tracker data is coming in, and do that thing automatically, or provide a GUI for just you can say, hey, I want to rotate this tracker data by 90 this or that, and then it will do a 4x4 matrix for you. So And also, something nice is, again, these are low-hanging fruits actually. You want to extend PVX to support more options, such as, you want to separate the eye with the stereotypes. So you want to say like eye equal to left, and then the stereo would be anaglyphic or crystallized. So right now it's put into one option, which makes it difficult to say I want to use anaglyphic as well as eye. It assumes that when you do left eye, it assumes that you're going to do crystallize. So these are some low-hanging fruits that we can take care of in near future. And if there is any particular need that you might have, we can do more work. With that, we're going to show the demo on Linux now. Do I need to move? No. So while Bill is setting that up, anyone has any doubts or any questions that I can answer? So how many people actually know VTK or ParaView, I guess? That's my curiosity is. So the ParaView has developed quite a bit, and I think in the future is gonna change even is gonna include more features and sources. And the mailing list of ParaView is very active. I think we get around like more than 25 emails per day. It's pretty active mailing list, and different companies, different research labs are involved. So if any of you actually has any need or think that they can leverage ParaView, check out the source code, start using it. You don't have to pay any single penny to Kitware, but if you need any help, we are more than happy to help. The most of the benefit that Kitware can get from you, I guess, is the collaboration and future work, and not necessarily like helping you out with some feature requests or bugs or bug fixing and whatnot. So again, it's pretty active community, both VTK and ParaView. The website is vtk.org and paraview.org, so you can go to the websites. There's a bunch of documentation for those things. Obviously, the documentation is never enough, so there's some documentation missing for development of ParaView or ParaView VR, but we actually updated the ParaView VR wiki, and then we have a step-by-step directions how to compile ParaView on your own system. So if you need to do that, feel free to try that instructions and then get back to us if you run into some issues. Okay. So again, same thing here. We're gonna do the demo on Linux. One thing actually we're doing a single screen because we realized yesterday is that the ParaView does when you do like slicing and whatnot, it consumes CPU cycles quite a bit, and then we had some issues there where the daemon would not work when ParaView tried to get to the CPU. So we had to we're right now showing on your one screen, but again it depends more like how you're running the GUI, I guess, or the GUI daemon. So it's a set of a specific limitation right now. Okay, so let's see if we can just connect to the. So let me do a simple demo. And thanks to Bill, he already configured some of these things for us, so it makes it easier for me to. It makes it easier for me to actually, run these things. So here we are using actually GUI protocol. It's just because, yeah. So it's just using. Hang on a second, Sam. Okay, there you go. So here we are using GUI because that's what the cave is set up like that. Oh, did it die? Is the tracker working? Oh, we didn't set the. I think the. Oh, you did? You did really nice, huh? Let me run again.
So like Ashish said, this machine has only, I think, 4 cores on it there, right? And we discovered last night that when you do big data, it starves the tracking process.
Yeah, let me try to restart and see if it. Huh? Oh yeah, I have to start this one as well. Oh yeah, yeah, I think here. No? Maybe. Oh, you're doing okay. Let's try that. Try that. Sure. Thanks. Okay, let's give it another try. Is tracker working, Simon? Yeah. Okay, so if you so I'm gonna show animation here. Again, simple animation. This is this that comes with ParaView. So so you can start doing animation. Again, simple thing, but it just shows you that you can do animations within the VR framework. And you can look at the datasets right here, or you can do the interactions right from there. And one thing actually you can do, and that's the nice thing about that, is you can do different. You can use different transform filters or different coloring filters to present your dataset in different ways. So you can use the global cell IDs, or whatever the this is the cell dataset, and you can choose the different modes. You can say surface with wireframes, or you can just do wireframe, right? Or you can just do points. So again, it's pretty much all the power of ParaView. Is basically comes with with the VR plugin. Like I said, if you do the volume right now, I think it's going to hang. But that's a work to do for the future. Okay. So, I'm not done yet. But this will be the last. So we're very close. So I'm going to show you the bike dataset, and here we try to do the slicing thing and see if it works. Okay, so let's see. So again, here's a bike, and what I've actually done here is that what Simon is doing is he's using a new interactive style that we have developed for supercomputing. Again, it's just for a demo type, so it's not it's not used in any particular. Huh? Well, I did, yes. But I guess should I? Well, let's do the demo, and then we can try to do it in the studio as well. But basically, so you can right now you're doing, and again, this feature that when you actually moving the slice plane, it's not slicing or clipping the dataset. It's in the interactive style. If you want that interactive clipping or slicing, you can do that in your interactive style. Or if somebody wants to expose that feature in the VR panel, they can do that. It's just that for our prototype, we thought it's like easier to move the slice plane and not to do the slicing or clipping at that time, because these operations could be data and compute intensive, and it may kill your interactivity. So again, we can move the slice plane, you can rotate the slice plane, And this particular thing we use the slice style, but actually this could be used for other purposes as well. So we should probably rename it to like position and orientation style, but right now it's called slice style. So should we run the stereo mode or? Okay. So again, like I said, we say stereo, dash stereo, and say stereotype to crystal eyes. Huh? Sure. Hey, we can change the name. I have no issues with that. Okay. And probably we should, because this is not. I did not rename that style. Actually, it's somebody else at Kitware. Okay. So I'm gonna reset the camera, and then I'm gonna start, and I'm gonna select this thing. So now it's in stereo. So again, our real intention is to bring the power of the ParaView in the immersive environments. And I don't think we are really constrained by anything, because we already have solved all the hard problems. I think if you ask me, to be very honest, I think the thing that you work on is just to make it easier and make some of these interactions even nicer. And make it even easier for the user to configure these things. So you can just do one button click and hey, it's configured for your VR environment. And I think personally I like the idea of IQ Station, and Bill and Eric and Patrick has a paper on that. I think that's a fantastic idea. I would like to see these kind of things people doing on their desktops with these stereo monitors coming in. I think it makes it possible to have that vision. Also, we want people to use, the new interaction, ways like with leap motion and whatnot, and use that with the ParaView, and eventually expose those features for the VR plugin as well. So it's all possible. It's just a matter of time for now. I think with that, that's my talk. Thank you so much.